So, did you have any questions on anything so far? I guess we're going to start, I think, the next chapter. We started it, didn't we?
Yes.
And we got to number 10, not through it?
Yeah, we got to number 10, not through it.
Yeah, okay. So number 10 says, three different angles in the following figure have Q as a vertex. Name each one of them. So, what are the three angles that have Q as a common vertex?
PQR,
Okay, angle PQR,
PQS, and SQR.
PQS, and then SQR. Right? All right. B, it says name two pairs of adjacent angles in the figure. Adjacent angles are ones that share a common side and a common vertex.
Two of the ones we just named.
Yeah, or you could go back down and get the bottoms. So, but it just says two of them. So it's angle PQR and
PQS.
PQS. Yeah, excuse me. And then angle SQR. So those are adjacent. So 12. It says how many different angles are shown in the following figure where T, S, and W are collinear.
First, can you refresh my memory on collinear?
Means they're all laying on the same line. So, how many different angles? So you have like T, S, and then you could go U, right?
Mm-hmm.
And then angle T, S, D, and angle T, S, W. Now if you start from the other side, you could go W, S, V, W, S, U. This is a V. It's a U. You see one more. There's
VSU.
okay. That's the one that's a little bit harder to see. VSU. So there's 6 of them. Now it says the B part, how many are obtuse? And obtuse are what? Angles that are
Larger than 90.
or less than 180, right?
So then would it be just the two?
Yeah,
TSU and TSV?
yeah. There's just 2 of them. The straight angle don't count because it's less than 180, larger than 90. How many pairs of angles are supplementary? So supplementary means what? Add to a 180, right? Add to 180. So if you list them, you have angle TSU and what? What's its angle that makes it supplementary?
Then it would be USW.
Okay. then it's angle TS, this was U, TSV, and angle
ESW.
VSW.
So these are two pairs.
Yep. So 14. Now, those angles, I'm not going to ask you a problem like that because I'm not expecting you to get a protractor. And anyway, if you got a protractor and you measured it, you know, the chances of getting an exact measurement would be small. Everyone coming up with the same one. So 14, they're just saying it's a 85-degree angle. So what kind of an angle is it? Acute, obtuse, or reflexive? Straight or right? If it's 85. 85 degrees. If that angle is 85 degrees, what is it? You said acute. So B, and they're going to call that angle 129 degrees. So what is that? What would you call that one? Obtuse. Okay. And then they're going to call, now C, what they're going to do is they're going to call that 100 degrees, and now they're not letting it be reflexive.
Right.
They're making it come down,
Measuring from the under.
yeah, or else one side over to the other in the 0 to 180. And so this is going to be what?
It's also obtuse.
Obtuse. But like I say, I'm not gonna have you, unless there's numbers like this next problem where they're gonna give you numbers on the angles and ask you what the size of the angle is. So 16 could be a viable problem. So probably I should attempt to give some sort of semblance of what this thing is. Now, what this one is said to be a right angle. And then they have A out here, B up here, C, and then D, and then they call this O. Now they're saying angle AOD is 150 degrees. So AOD, so the measure here is 150. And then they're saying BOD, so this one right here is a 72. And then they want the angle, the measure of angle AOB.
So you would just subtract 72 from 150.
Okay. 150 minus 72. 78. and then they want BOC, a measure of angle BOC. BOC. So what we actually have figured out, right, is, let's see, we've got this one right here at 78 degrees, right? And then we want BOC. You see AOC is 90 degrees, isn't it?
Mhm.
And then you got AOB is 78. So what could you do? What would you do to get BOC? 90 degrees minus 78. Are you right? Okay, so that's 12, isn't it? Okay. 16. It says in the following figure, the measure of angle 1 is 14 degrees less than the measure of angle 2. Find the measures of 1 and 2, round your answers to the nearest hundredth of a degree. Ah. What they have, since that's 90, and you got this one. Then they call this one angle 1 and this one angle 2. Again, we're talking about measures. Rather than writing angles, we could let it be like that, right? X and Y as measures.
Do you really want the two variables? Could you use just one variable?
I guess you could, but I'm just going to,
Right, for clarity.
yeah. See, it says angle 1 is 14 degrees less than twice the measure of angle 2. So angle 2, so let's see, I don't know. This angle 1 equals twice angle 2 minus 14 degrees, right? And then 1 plus 2 is 90 degrees, right?
Right, comes out the same way, understood.
And then you can use the substitution. So then you could just go 2y minus 14 plus y equals 90 degrees. So 3y equals 76. sure don't like it coming out to be a decimal. I wrote that formula right, didn't I? The follow through.
Because you gotta add 14, not take away 14.
Yeah.
Okay. Measure one. Measure one. It's 14, yeah, okay. So. Three y equals. Well, if it was minus, oh, I see. Okay, let's see, I better go back and what you told me to do. This was right? 2y minus 14. But then this, when I manipulated it, I manipulated it wrong. Minus 14. So then this is 3y and I add 14, 104. Is that right? Angle 1. Now that's 28, right? 20y. So this one is 28 degrees. And then this is 62 degrees.
Professor, the arithmetic is wrong.
Yeah, 145 degrees.
It's gotta be
30,
34.5.
38.
34.
I guess I can't even divide.
34 and 2/3.
Is it 2/3?
Yes.
It's 8, isn't it? 3 goes into 1 over 4. 3 is 9. Oh, it's 14. Okay. 34. Boy. 2/3. That whole thing doesn't sound right. Yeah, I guess it is. So this was 34 and a third, 2/3.
2/3.
And then that one is 50, 55 and 1/3.
Yes.
Oof. Lots of math errors. Okay. 20. The measure of angle X is 9 degrees more than twice the measure of Y. X and Y are supplementary angles. Find the measure of X. Well, measure of X, I'm just going to call it X. And the measure of angle Y, I'm just going to call it Y. So then it says the measure of X is 9 more than twice the measure of Y. X equals 2Y plus 9. Is that right? 9 more than twice Y. And X and Y are supplementary. So X plus Y is 180. Have I done it right so far? 2Y plus 9 plus Y equals 180. So 3Y, now I subtract 171. 3 5 15, 21 is 7. So Y is 57 degrees. And then is 57, then x equals 2 times 57 plus 9. 15, 223. Now, do you agree with me? Do you agree with, okay. Or I agree with you, one or the other.
123, sir.
123?
Huh?
Okay. I can't add here. One 23. 20. Okay. Here's one that tests your brain. It says 3 points are located in a plane. There is one line that can be drawn through them if the points are collinear. If the 3 points are non-collinear, then there are 3 lines that can be drawn through pairs of points. Therefore, 3 points, there is the greatest number of lines that can be drawn through pairs of points. 3 is the greatest number. Determine the greatest number of lines can be drawn through 4 points, 5 points, and 6 points. So 22. So 3, this is the number of points. And this is the lines. So 3 points, there are 3 lines. When there's 4 points, so if you go 4 points, there's 1, 2, 4, 5, 6, right? Is that right? 6. And then if there's 5 points, so you got 1, 3, 5. So you got 5 lines around the outside. 5. Then you got 6, 7, 8, 9. Is that it? So there's 9. And then if you go 6 points. 1, 3, 4, 6. So 1, 2, 3, 4, 5, 6. Then there's going to be 1, 2, 3. Then if you go to this one, 4, 5, 6. And if you go to this one, 7, 8. And then if you go to this one, the only one that there's one left, 9. Is there another one? 9 again. That don't seem right. There were 6 around the outside. Then the red, there's 1, 2, 3. The green, 4, 5, 6. And 7, 8, 9, and 6. That's 15.
Yeah, I get 15 lines as well.
I just quit counting. I went back to 1 after I counted the ones around the outside. So that says, is that right? It says generalize to n points.
Professor, the one with 5 points is 10 lines, not 9 lines. My counting. 1, 2,
Oh yeah, here's another one. You go over here and there's one here.
okay, yeah.
There's 3, 4, 5. You know, whenever it's like this, it's always that n times n minus 1 over 2. Every time we've had something that did a progression like that, it always turned out to be that. And I don't know, I guess I don't know enough about progressions, but there's and I never took the time to.
We did something like this in another class, but I can't remember exactly which class or exactly what the progression was.
Yeah.
But that looks very familiar.
Yeah, it's whenever it just, for me, whenever this difference between these it goes up by 1, it's always that n times n minus 1 over 2. Seems to me like. Okay. Well, you don't have to be too afraid of having something like that, because I don't know quite how to explain how you get it. So. (24) It says convert each of the following angle measures to degrees and decimal fractions of a degree, round to the nearest thousandth of a degree. So A is 189 degrees, 51 minutes. Now, the way I do it, I don't know whether this is right, you add 51 minutes, and then you go 1 degree is 60 minutes. I always like to do, those kinds of things where you do conversions. And then your unit cancelization. See, if you wrote minutes out here as a unit and you wrote minutes out here, then the minutes would go away and you'd have degrees left. That's the way I like to always do things that have units, is do unit cancelization. Then you know that you're using, whether to use 60 over 1 or 1 over 60, you can see you want to get degrees, so that you can see degrees is left in the numerator. Do you see what I'm saying? You probably learned that before. Huh? Yeah. So it's 60 over into 51. How many times does that go? 48. 6 8s are 48. 80? That's 48, isn't it? 0, 3, 0. Now it's 3.
5.
Oh, yeah, 5. Ooh.
And what would this be used for? For compass headings?
Plus 0.85. Well, it's, I guess, if you're trying to convert it somehow, and probably if you were doing azimuths or headings, you would do it. So this is 189.85.
So I'm guessing the symbol in B would be 54 seconds. That's the one symbol is minutes and the other double symbol is seconds. Okay.
Yeah. So what you do is it's 220 degrees, 36 minutes and 54 seconds. So you do 22 degrees and you add 36 minutes, 1 degree is 60 minutes, and then you'd add 54 seconds, and you'd say 1 degree is 3,600 seconds. 60 and 60. I think that's 3,600. So then you'd have to divide the 60 into the 36. And that'd be 0.6, wouldn't it? So this is 220 degrees plus 0.6 degrees plus, and then you'd add
Professor, I hate to stop eating your work, but you have to start with 220 degrees for the first.
was it 220? Was it 222, huh?
220.
Okay.
Before you do all that work for nothing.
Yeah. Now 36 into that, that's once, isn't it? So it's 0, 1. 8, 18. How many times? That's 5, isn't it? I think so. So that's 0.015 degrees. So it's 220.615 degrees. You see any other errors that I did when I divided or multiplied? Are we good? Does that look good? Okay. I'm not going to do C and D, it's just more the same. So I'll go 26. It says convert the measures to degrees, minutes. Round off to the nearest minute. So then this 175.95 degrees. So you go 175, and then what you do is to get degrees. Now to get minutes, you'd go 95 degrees, and then you want to get minutes, so it's 60 minutes over 1 degree. So you multiply that. So it's 0.95 times 60. Is that right? 175 degrees, 57 minutes. Is that right? Did I multiply right?
Yes.
I'll do C. I mean, it's the same process, 87.19 degrees. So you go 87 degrees and you go 0.19 degrees, and then you'd have 160 minutes, 1 degree. I don't know, for me, if I don't do that unit cancelization, I invariably will run it out wrong. Now it says to round 87 degrees in 11 minutes. because you'd round down, I guess, if I multiplied right. 0.19 times 60. 6 nines are 54, 5 to carry, it's 11, isn't it? So that's the way you do those problems there. It says convert the following angle measures to degrees, minutes, and seconds. So do A. 15.73 degrees. So I do 15, and then do 0.73 degrees, 60 minutes, and 1 degree. So then I take 0.73 times 60, 0, 18, 43. So at this point I get 15 degrees, 43.8 minutes. But now they want seconds. So then what you do is you take that, you're going to do this, 15 degrees, 43 minutes, and 0.8 minutes. So now what you have to do is you got to go 0.8 minutes, and you got 60 seconds in 1 minute. So make sure you don't do 3,600. So then 0.8 times 60, 48. So this is 15 degrees, 43 minutes, 48 seconds. This one, you know, when you're doing degrees, minutes, and seconds, you got to divide by that 3,600. But when you're doing it this way, when you got the decimal in the minute, you got to make sure that you multiply by 60 seconds in 1 minute, and that's why that unit thing, unit cancellation is pretty important, so that you don't, so that you kind of get it right. Then it's pretty just mechanical. I'll do C. It says 1, 1, 2, 2, 2, 2. So it's 1, 1, 2 degrees. Then it's 0.222 degrees. And then I got 60 minutes, 1 degree. So I take 0.222 times 60. 0, 12, 13, 13. And then 3 decimal places. So this is 112 degree, 13 minutes, and then 0.32 minutes. So then to convert this to seconds, I gotta do 60 seconds, 1 minute. So I take 0.32 times 60. 2, 19, 2 decimal places, 112 degrees, 13 minutes, and then you round down 19 seconds. Did I do all my math right?
We gotta have a calculator on the
Oh.
top.
I got a granddaughter that's in the first grade. Okay, anyway, I digress. All right, 30. It says, an air traffic control tower is located at the origin of the following figure. The locations of the four planes are A, B, C, D are indicated by dots. For each plane, give the bearing from the control tower. Also give the bearing from the control tower from each plane. Now, I'm not going to give you this and expect you to know the bearing to the point, but if you know the bearing to the point, you should be able to get the bearing
Would be
back.
the opposite.
Yeah. So what we'll do is I'll draw this thing out. Let's see. There we go. This is point A. B is down here. It's kind of in this neighborhood. D is no, I'm just gonna kind of now A, and the bearing is always going to be north so many degrees, one way or the other. So what it's going to be. So,
Are they looking for an exact degree, or are they?
yeah, but the thing is, when I give you the problem, I'm gonna give you these angles, and then you'll have to tell me. So let's see, 30. So this one, this angle right here is going to be 60, and that angle right there, that's to D, right? That's 40, and then that angle B, 15. And just to facilitate doing this, let's see, this is 30. Now, if I gave you, remember this, if I gave you any of these angles, you would have to convert and get the angles away from north and south, right?
Mhm.
For the bearing. Now, if we go from the control tower out, and I'll put that in red, what would A be?
30.
North, 60 degrees. And I always got to remember north, and when I'm facing north, west is on my left and east is on my right, right? Because this is north. So this is west, isn't it? Left. Is that right?
And that's how they classify it.
Yeah, that's how you do it. Then this one would be north 40 degrees east. And then this one would be south 15 degrees west. And this would be south 30 degrees east. As long as I got right north, when I go north, east is on my right, west is on my left, right? Is that right? See, this is east, this is west, and this is south.
So Professor, I'm assuming the book, the architects want us to put a protractor on that diagram,
Yeah, but only if this is what I'm telling you.
okay,
I'm either gonna give you the green percent degrees or red degrees
okay,
for the problem. And then I'm gonna ask, what's the bearing?
okay.
Does that make sense?
Mhm.
That's the way I'm gonna give it. Now, if you go from A back to the control tower, and let's do that in blue, what is that gonna be? See, just remember this. Here is the plane, there's the control tower. So you're going to go south so many degrees east, right? Now this is what you want to look at. You see, when this dashed line with this blue intersects with the north-south line, these angles here are, you know, across from each other, so they're equal, right?
Mhm.
So this angle right here is going to be 60 degrees. Do you see what I'm saying? So now then you'll call this what? South 60 degrees east.
So the angle remains the same,
Yeah.
but you just swap
Yeah.
it.
But you see why you see why the angle's the same, because the north-south line is one line, and then that dashed line extended is the other, and then that 60 degree line, those are opposite angles, right? Of two lines meeting. Those are always equal.
All right, so an example, the bearing from D.
See, if you go this and you go this way and you know this angle, it's equal to this angle.
Right.
So then you'd go another line here that's parallel to this line, and this line angle and this angle.
It's a lot simpler than it seems.
Yeah. So do you see how you would do it?
Yeah. Mhm.
Okay. So, do you understand that when I give you the problem, what I'm gonna do? Is I'm gonna give you, and I'm not gonna give you probably on a quiz or test, I'm not gonna, this would take probably 10 minutes in itself just to try to figure it out. I would give you one thing, and I might not give you the diagonal angle, right? I might give you the 40 degree angle down here, and then say, what is this bearing out to that? Well, then you'd have to subtract that from 90 to get 60, and then do it. You understand what I'm? Okay. So you want to look at those things and kind of have a figure.